I'm going to give you some general probability examples here. Now, I might go a little quickly on some of these, but you can always pause the video or slow it down if you need to. But I want to get these all on one video. So, first of all, look at this first one. This first one's pretty straightforward. You have an experiment, and you're going to draw from the numbers 1 through 9, and it says what is the probability of the outcome being an odd number. Well, there's actually 5 odd numbers in this sample out of 9, so the probability would simply be 5 out of 9. The second one is probably just as simple. A single card is drawn from a deck. Find the probability that a face card is drawn. Well, if you count the number of face cards in a deck, you'll find that there's 4 jacks, 4 queens, and 4 kings. So that's 12, so the probability would be 12 out of the 52 cards, which is 3 out of 13. Now, on this next one, it says a committee of 4 people is going to be chosen from a group of 5 men and 6 women. What is the probability that the committee will consist of 2 men and 2 women? I'm going to draw you a diagram for this. So look at this diagram. At the top of the rectangle, I wrote the total number of objects I have. That would be 11 people. And at the bottom, I'm showing you the number that we're going to select, which is 4. So from those numbers, I can determine that my denominator is going to be 11 choose 4, because that would be the total number of samples of 4 people I could choose out of 11. And then in the rectangle, I've broken it up into men and women. Now remember, I have 5 men and I have 6 women. And I want to choose 2 from each. So the number of ways to choose 2 men from 5 would be 5 choose 2, and the number of ways to choose 2 women from 6 would be 6 choose 2. So my numerator would be 5 choose 2 times 6 choose 2, and then divide it by 11 choose 4, and I get 0.4545. On the next example, I'm going to use a Venn diagram. So we have a total of 50 students. So this rectangle will represent my 50 students. There's 23 majoring in psychology, so that would be this first circle represents the 23 that's majoring in psychology. 16 in sociology, so the second circle represents the 16 in sociology. 7 are majoring in both, so I'm going to put 7 right in the middle. And then I can take 7 away from 23 and get that there's only 16 that's majoring only in psychology. Take 7 away from this 16 and I get 9 that's only majoring in sociology. And then if you add these 3 together, you get 32. Subtract it from 50, you get 18 that are majoring in neither. And then once you get this filled out, you can answer any question. How many are majoring in psychology alone? Well, that would be the 16. So we're looking for probability though, so the probability would be 16 out of 50, which is 0.32. And then what's the probability that they major in sociology alone? Well, that's 9 out of 50, 0.18. And then the probability that they major in either one or the other, well, that's a total of 32 out of 50, so that's 0.64. And then majored in neither, that would be the 18 out of 50, so that would be 0.36. And then not majoring in psychology, that would be the 9 here plus the 18 here, which is 27. So 27 out of 50 is 0.54. Now on number 5, you could do a similar diagram that I did on number 3, but you don't have to do that. But just remember, you have a total of 27 radios, and there's 4 defective. So that 27 breaks up into 4 defective radios and 23 good radios. You're going to randomly select 6 radios for display, and so we're asking what is the probability that 2 are defective. So that means 2 defective and 4 non-defective. Well, let's do our denominator first. First of all, we need to figure out how many 6 radio displays are possible. So out of 27 radios, we can do 27 choose 6, and that will tell me the total number of 6 radio samples available. And then we want to determine of those samples how many would have 2 defective and 4 non-defective. Well, to get 2 defective, we would have to say out of the 4 defective radios, we got to choose 2, and out of the 23 good radios, we're going to choose 4. And then so we multiply these together and divide it by 27 choose 6, and I got 0.1795. Number 6 is a similar example. It says 8 cards are drawn from a standard deck of 52 cards. what's the probability that there are 4 face cards and 4 non-face cards? Well, again, we're drawing 8 cards out of 52, so the total number of samples possible would be out of the 52 cards, choose 8, so that would be your denominator. And then you want to know how many of those samples would have 4 face cards and 4 non-face cards. Well, there's 12 face cards, and we want to choose 4. And then so that means out of the 40 non-face cards, we would also have to choose 4. So if we multiply these two combinations together and divide by this combination, we'll get our answer 0.0601. This one basically says if you draw 5 cards from a deck, what's the probability that you get exactly 3 hearts? Well, first of all, the denominator represents the total number of 5-card hands, so that would be 52 choose 5. And then the numerator would be how many of those hands have 3 hearts. Now to have 3 hearts, that means you have to have 3 cards that are hearts and 2 cards that are not hearts. So out of the 13 cards, you want to know how many ways you can choose 3 hearts. That 13 hearts, how many ways can you choose 3 of them? And then there's 39 cards that are not hearts, and you want to multiply by the number of ways you can choose 2 cards that are not hearts out of the 39 cards that are not hearts. So multiply these together and divide by this to get your answer. And then number 8 says a committee of 6 people is chosen from a group of 6 men and 5 women. What's the probability the committee will consist of at least 4 men? Well, if you let E be the event of getting at least 4 men and think about what it means in this example, since we're selecting 6, that means you could have 4 men or 5 men or 6 men. So what you have to do is you have to figure out how many ways can you get exactly 4 men. So to get 4 men, that means out of the 6 men you choose 4, and out of the 5 women you choose 2. So there's 150 ways that can happen. Then you have to figure out how many ways can you get exactly 5 men, which means 6 men choose 5 and 5 women choose 1. Multiply those together to get 30. And then how many ways can you get exactly 6 men? Well, that would be 6 men choose 6 and the 5 women choose 0, so that's 1. And then add these 3 numbers together and you get 181, and you divide it by the total number of 6 people committees that could be selected, which is actually 11 choose 6, which is 462. So you get 181 out of 462, which is 0.3918. The next example is an empirical example. So we have some results here in this table based on some voters that filled out some polls. So you have 3 areas of the city, and you have 3 choices. They either favor it, they oppose it, or they have no opinion. And then the information, the number of people that fell in each category is given. And I also gave you the totals of each column and each row. Okay, so we want to know the probability that if we select one of these people, they'll have no opinion on the issue, or they live in the inner city. Now this or is a union. So what you have to do is to get the number in a union, remember we have to use the addition principle. So you have to find out how many have no opinion. So there's 200 that have no opinion. And then you add to that the number that live in the inner city, which is 245. And then you subtract from that the intersection of these 2 groups. So no opinion, inner city, the intersection is the 85. So take 200 plus 245 minus the 85, and that'll give you 360 out of 500 there. Let's see. I got 500. I said 490 there. Let me check that. Okay, it is 500, so that's my bad there. They do add up to 500. Okay, so anyway, it's 360 out of 500 for this one, which is 0.72. The second question says being in favor and living in the east side. So we need to look for the intersection. Well, here's the being in favor, and they intersect the east side right here at this 30. So that would be I'm sorry, that's C. Being in favor and that living in the east side is C. So C would be 30 out of 500, which is 0.06. Okay, sorry, I hope I didn't confuse you there. That's part C. Okay, but then B is being in favor of the issue. Well, being in favor of the issue, that would be the total of this column, which is 150. So that would be 150 out of 500, which is 0.3. And then the last one says not being in favor. Well, not being in favor would not only be the opposed, but will also be those no opinion. So you add those two together and you get 350 out of 500, which is 0.7. Here's a couple of challenge questions. I usually don't ask anything like this on a test, but in the game of poker, find the probability of getting a 5-card hand consisting of a full house. That would be 3 of one number and 2 of another. So for instance, like 3 kings and 2 fours. So I want you to think in terms of 4 operations here, because there's got to be 4 operations satisfied. Operation 1 would be the number of ways that you could get the first kind. In other words, whatever you're going to get 3 of. So since there's jacks, queens, 10s, 2s, 3s, etc., there's actually 13 kinds. So there would be 13 of those. So there's 13 ways. There's actually, you could get 13 aces, 13 2s, 13 3s. I'm sorry, I said that wrong. You could get 3 aces, 3 2s, 3 3s, 3 4s, 3 5s, and so forth. So there's 13 kinds that you can get 3 of. And then the question is, how many ways can you get 3 out of 4 of each of those kinds? Well, there's 4 ways to get 3 aces out of 4 aces. There's 4 ways to get 3 2s out of 4 2s. There's 4 ways to get 3 3s out of 4 3s, and so forth. So for each kind, there's 4 ways that can happen. So anyway, so there's 13 kinds that you can get 3 of, and there's 4 ways to get 3 of each of those kinds. Now, the second kind would be, we'd have to make that 12, because whatever we got here, we can't get here. So there would be 12 left. And then of those 12, we want to get 2 of those. So of those 12 kinds, there's 2 out of 4 ways. We want to figure out how many ways we can get 2 out of the 4 of those kinds. So 4 choose 2. So there's 6 ways to get 2 out of any kind. So there's 6 ways to get 2 aces out of 4. There's 6 ways to get 2 kings out of 4 kings. There's 6 ways to get 2 queens out of 4 queens, and so forth. Then we have to multiply each of these operations together, and you get 3,744. And then if you divide it by 52, choose 5, you get 0.0014. Now, I think I've already done this one in the notes and showed you that there's only one way to win at Texas Lotto. So I won't do this one again, but the probability of winning the jackpot at Texas Lotto, if you buy a ticket, there's one way to win, and there's 54, choose 6 possibilities in Texas Lotto. Okay, let's talk about roulette real quick. Most roulette wheels contain the numbers 0, 0, 0, 1 through 36. 0, 0 are green, and half of the other numbers are red while the other half are black. So if you bet on red, what's the probability of winning? Well, if you bet on red, remember there's 38 total spaces. There's 1 through 36, red and black, and then there's these 2 zero spots. So that's 38, and there's 18 ways out of red. There's 18 red, so 18 out of 38 would be the probability that you win. Now if you bet on green, what's the probability of winning? Well, there's only 2 green out of 38, so the probability would be 2 out of 38. Now if you bet on the number 7, what's the probability of winning? Well, then you would only have a 1 out of 38 chance of winning, because 7 is just one of the numbers, one of the 38 numbers. Okay, I'll wrap it up on the game of craps. On your first roll in the game of craps, you win if you roll a 7 or 11. So what's the probability that you win on the first roll? Well, there's 6 ways to roll a 7. There's 2 ways to roll an 11. So there's 8 ways you can win on the first roll. So the probability on the first roll would be 8 out of 36, or 2/9. And then what's the probability that you lose on the first roll? Well, you lose if you roll a 2, 3, or 12. And there's actually 4 ways that can happen. So that would be 4 ways out of 36, which is 1/9. Now, the second question says, what's the probability that you continue after the first roll? If you roll another number in the game, the game continues and you roll again. So actually, I probably stated that incorrectly, but what's the probability you continue after the first roll? Well, there's 24 ways that you could continue. So that would mean that you've got 24 possible rolls to continue. So that's 2 out of 3.